Okay, so I see that you need help with this question, and it says a soft drink manufacturer purchased aluminum cans from an outside vendor. A random sample of 70 cans is selected from a large shipment, and each is tested for strength by applying an increasing load to the side of the can until it punctures. Of the 70 cans, 58 out of the 70 meet the specification for puncture resistance. If a 90% confidence interval is computed each for each day for 300 days, what is the probability that more than 280 of the confidence intervals cover the true proportions? Round your answer to 3 decimal places. So, um, so what is the probability that more than 280 of the confidence intervals cover the true proportions? So it wants to know 280 out of 300 days. So, excuse me. So 58 divided by 70 is 0.83. And 280 divided by 300 is 0.93. Okay. So if I take 0.83 plus or minus for a 90% confidence interval, that is 1.645. And that is multiplied by the square root of 0.83 times 1 minus 0.83 divided by 70. So I have 0.83 plus or minus 1.645, and then 0.17 times 0.83 divided by 70. That's square root of 0.002. So the square root of 0.002. And so I have 0.83 plus or minus 1.645 times 0.0447 times 1.645, and that's 0.83 plus or minus 0.074. So my confidence interval will be 0.83 minus 0.074, and that's 0.756. And then if I add them together, that is 0.904. So that's not even going to hit that. Then it says B, if a sample size is needed for a 90% confidence interval to specify the proportion within plus or minus 0.06, round up the answer to the nearest integer. So 0.06, okay, equals, if I do 1.645x, so then x equals 0.06 divided by 1.645, that is 0.03647. And if I have 0.03647, so hold on, this is B, this is A, this is B, equals the square root of 0.83 times 1 minus 0.83, or actually, I have, it's 0.83 times 1 minus 0.83 divided by the square root of x. So then I have 0.03647 equals the square root of 0.83 times 0.17, and that's 0.1411 divided by x. And then if I square both, 0.03647 squared. That's 0.00133 equals 0.1411 divided by x. So then if I take 0.1411 divided by 0.00133, I am going to get, so it's 106, x equals 106.09. So I'm going to need x equals 107. I have to round up. Then it says, excuse me, C, find the sample size needed for 95% confidence interval to specify the proportion. Okay. All right. So then I have 0.06 equals, for 95% confidence interval, it's 1.96 x. So then that's 0.06 divided by 1.96. X equals 0.0306. Then I have 0.0306. And I'm going to end up squaring that. And that equals 0.1411 divided by x. So then I have, squaring that, I have 0.000933711 equals 0.1411 divided by x. So 0.1411 divided by 0.000093711. And that is x equals 150.6. Well, yeah, 0.6. So that's x equals 151. So 151 would have to be in the sample. And then D says, find a 90% confidence interval for the proportion of cans in the shipment that meet the specification. Round answers to 3 decimal places. So I found the 90% interval because I did it up here. 90% confident interval is the 0.756, 0.756, comma, 0.904. Then for E, find the 95% confidence interval. So that's 0.83 plus or minus 1.96. And then that's times the square root of, or times 0.047 times 0.047. And so 1.96 times 0.047. And that's 0.83 plus or minus 0.09212. So 0.83 minus 0.09212. And that's 0.73788. So to 3 decimal places, that's 0.38738, comma. And then if I add them together, that is 0.922. So I hope that this video helps you. This is the middle school math teacher signing out.